Molars. Molar is a teeth. How many molars we have? In a single, in a lower jaw, 3 this side, 3 this side. So let me explain you about our teeth and our dental arcade. Okay. So the first 4 teeth. 1, 2, 3, 4. These are incisors. After this incisors, we'll be having one teeth like this. Animal like teeth. For few, it may be pointed, and for few, it may be blunt. These are our canines. After canine comes 2 premolars. These 2 are premolars. After that comes 3 molars. Molar 1, molar 2, and the third molar will have a slight incurving. It curves inward like this. These 3 are molars. These 3 are molars. The same pattern will be here. We have 2 plus 1 plus 2 plus 3 pattern of teeth. In a single jaw, there will be 4 incisors, 2 canines, 2 plus 2, 4 premolars, 3 plus 3, 6 molars. Molars are the largest and the toughest teeth. The way in which the teeth are arranged in the lower jaw. Lower jaw is technically called as mandible. Lower jaw, this bone, right, is technically called as mandible. So the way in which the teeth are arranged in the jaw, that itself shows an evolutionary significance. For example, for the molar, for the apes, the primitive apes. By apes, we refer to Australopithecus, Homo erectus, Ramapithecus, Sivapithecus, etc. Okay. For the apes, for the most primitive apes, the teeth are arranged in U-shape. The lower jaw, three molar, 2 premolars, 1 canine, 1, 2, 3, 4 incisors. This is U-shaped, right? Can anybody tell me what is the shape of the human dental arcade? The human dental arcade is a parabola shaped. It is parabolic. Parabola is a graph. So when you draw parabola in a graph, it used to be like this. Parabola used to come like this. This is somewhere between V shape and the U shape. Parabola lies between V and U shape. Human dental arcade is also parabola shaped. It is parabolic. Okay. So come back to molars. Okay. These are the roots. The wearing pattern of the molar. Suppose this is the molar of gracile. And if this is the molar of robust. The molars of robust shows a greater wearing pattern. Shows a greater wearing pattern. So wear and tear you say, right? That is because of abrasion, because of biting, because of chewing, because of damage, right? There is a greater wearing pattern in the teeth of robust, but in gracile there is only a slight wearing pattern. There is no much damage in the molars of gracile when compared to that of robust. Now tell me, who should be omnivorous and who should be vegetarian? Robust were strictly vegetarian and gracile were omnivorous. Most of the vegetation like the fruits, tubers contains silica. Silica is one substance which creates lot of abrasion to the teeth. But here our gracile, they eat lot of meat. Silica is not found there in meat. But silica is there in fruits, vegetables, tubers, nuts, etc. So the presence of silica in the food of robust created a greater wearing pattern. So this shows that robust were strictly vegetarian, while gracile were omnivorous. In ecological sense, we call robust as a specialist, while gracile a generalist. Specialist means they have, say, even after getting into service, right? Once when you become an IPS officer, once when you become an IRS, you are a specialist. You will be specialized in law and order if you become a police officer. You will become a specialist in income tax if you become an IRS officer. But IAS, Indian Administrative Service, right? They are generalist. One day they will post you in revenue department. One day they will post you in transport department. One day they will post you in milk federation. One day they will post in the Zilla Panchayat. Only IAS, right, they can do this particular job. Okay, so once when they post you as a revenue official, there will be revenue court. On one day, right, you will be the chief executive officer of Zilla Panchayat dealing with Panchayat issues. Suddenly, very next day, right, they will post you as a deputy commissioner, district magistrate. In few states, we call them as district collectors. When they post you as a district collector, right, when you go and sit there, there will be revenue court. You are a district magistrate. You need to deal with, there will be a court where you need to sit as a magistrate and you deal with the cases. There all professional trained lawyers will be there arguing before you. Only an IAS officers, right, they are capable of dealing with such a condition. Suddenly, right, they will throw you into some new thing. Within a matter of time, you will be in a position to master all the laws and you can sit there and a judge to deal with the cases. That's really, really a challenging job, that is. Such a challenging career it is. See here, robust or specialist. That means they have only a very narrow range, they deal with only very narrow range of things. They have only a very narrow range of food materials which they can eat. On the other hand, gracile, right, they were generalist. They ate everything. Whatever is available, right, if it is eatable, they will eat. So as I told you, when there was a change in climate, when the climate changed and when the resources became scarce, when the availability of food materials became scarce, and even when the cold conditions didn't allow these people to live with comfort. There is a need for them when there is a strong wind. They need to protect themselves against the cold wind. They need to run. They need to hide in cracks and crevices to protect themselves against the cold wind. So under this condition, life became really horrible and pathetic for Robust. Because of its gigantic size, okay, they couldn't run fast. And because of their narrow food habits, they had only limited available resources to eat. On the other hand, that was not the condition for Gracil. Because it is short and slender, Gracil could run fast. It could go and hide itself in cracks and crevices. So, with the change in climate, Robust couldn't survive. Robust became extinct. And it is this Gracil which further evolved and which got adapted and it got evolved into Homo habilis. Homo habilis. Got it? So now I will discuss few species of Gracil and Robust which you are supposed to know. Okay, 4 important species in Gracil. Australopithecus ramidus. Australopithecus anamensis. Then we have Australopithecus afarensis, followed by Australopithecus africanus. This is according to the chronology, Ramidus being the oldest and Africanus being the latest. There is a mnemonic to remember this. If somebody asks you where is a Ram Anna, in most of the South Indian languages, be it Tamil, Kannada or Telugu, Anna, in Telugu they call Anaya. Anna means elder brother. If someone asks you where is Ram Anna, you can say Ram Anna is afar in Africa. Ram Anna is afar in Africa. Can you remember? Ram Anna is afar in Africa. Ramidus, Anamensis, Afarensis, and then Africanus. These are the 4 important and 4 prominent species of Gracil. Later, few more important fossils were also discovered, but there is no need to go that deep. For example, the latest discovery is like Australopithecus ethiopicus. Okay, so now please be comfortable with these 4 species at least: Ramidus, Anamensis, Afarensis, and Africanus. Okay, so in Robust, there are 2 important species. Few anthropologists refer Robustus by a separate genus called as Paranthropus. We can either call it as Paranthropus or Australopithecus. Both are correct only. So Paranthropus boisei. You can also say Australopithecus robustus, Australopithecus boisei. These are the 2 important and very prominent robust species. So before discussing about the general anatomical characteristics of Australopithecus, in brief, let us discuss about the geographical distribution of Australopithecus. Geographical distribution of Australopithecus. As of now, we couldn't find any Australopithecus fossil outside Africa, and most of the African fossils are found or were discovered from the southern part of Africa, in South Africa, in Kenya, in Tanzania, that is eastern part of Africa, and few in Ethiopia and Chad. So I have given you some list of sites. For example, those found in South Africa, right? We have in Tayung, Sterkfontein, Kromdraai, Makapansgard, Swartskran, etc. And I have also mentioned about a few other sites in East Africa. The most importantly, the Old Voi Gorge. This Old Voi Gorge is a very important site in Tanzania. It lies in Tanzania-Kenya border. This is one site from where hundreds of fossils were discovered. Fossils of Australopithecus, Homo erectus, and even subsequent primates, subsequent hominids. Got it? Okay. I am giving you a small assignment. In your notes, right, you can see all these sites. Try to draw a map of Africa. It's very easy. Very easily you can draw, right? How easy it is to draw Africa. So you need to practice this, okay? And all these sites, now we have Google Earth or Google Maps. In Google Maps, right, try to locate these sites and try to mark it. Where we have Swartskran, Mapakan Birds, then Tanzania here and Chad. So try to mark these sites. I want you to do it. Then only these things will remain in your head. Please take down, this is your first assignment. Draw a map of Africa and try to mark these sites where Australopithecus were discovered. Got it? So now let us discuss the characteristics of Australopithecus. This, right, we can broadly classify into three. The first one is this cephalic region. By cephalic, this refers to head. The cephalic characters. That regions associated with head is called as cephalic. This is cephalic region. Okay. Then number two, dentition. About the teeth, about the characteristics of the teeth. Then the post-cephalic, or you can say post-cranial. That is the entire body below the head. Entire body below the head. That we call it as post-cephalic. So first let us discuss the cephalic characters of Australopithecus. So cephalic. I told you by cephalic we refer to the head region. The first important cephalic character of Australopithecus is its cranial capacity or cranic capacity. What do you mean by cranium? I told you cranium refers to a collection of bones which covers and protects our brain. Okay. So I also we also had a small discussion about few important regions of our cranium. I told you about frontal, parietal, occipital, and temporal. Do you remember all these things? I'll do it. See, once again, I will show this. This is parietal, frontal, occipital, and the temporal. Okay. So by cranial capacity, what do we mean by cranial capacity? By cranial capacity, we refer to the capacity of the cranium to hold a brain. Indirectly, we refer to the size of the brain. By cranial capacity, we refer to the size of our brain. How large is our brain? For Australopithecus, the cranial capacity is 400 to 530 cc. Cc here refers to cubic centimeters. Cubic centimeters. Okay. So the cranial capacity of Australopithecus is 400 to 530 cc. For our modern human beings, the cranial capacity is around 1400 to 1500 cc. So that means the brain of Australopithecus, right, is roughly one third the size of the brain of human beings. It is a very small brain. But though it is a small brain, when compared to the other contemporary apes, when compared to the other apes which lived during the time of Australopithecus, there is an improvement in the brain. Relatively, in that particular period, between 4 to 2 million years ago, this brain size is relatively larger when compared to the other Miocene apes or apes which lived during that period. Okay, and there is an enlargement of brain, and this enlargement of brain, right, is largely found in the cerebrum and in the cerebellum. I hope you know about the three important parts of the brain: cerebrum, okay, so there was first of all, there is a greater development of brain in the cerebrum, the forebrain. So, also try to Google and see the various regions of the brain. Okay, where is cerebrum, cerebellum, and medulla oblongata in the behind. Okay, so there is a greater enlargement of brain in the cerebrum, mainly in the parietal regions. Guys, I hope now you will not have any doubt in this particular thing. Parietals. Parietals means these two lobes, right? These are parietals. This is frontal. Frontal, parietal, occipital, and the temporalis. Okay. So there's a greater development of brain in the cerebrum, mainly in the parietal regions. These are the regions of the brain which are associated with sound production. The speech, right? The speech, the words which we are speaking, the language of speaking, this was largely because of the development of brain in the parietal regions. So the development of brain in the parietal region of Australopithecus suggests that Australopithecus might have had some sort of a verbal communication, some words to communicate. They might have spoke at least something. Hey, stand here. Hey, give that to me. Give me a smile. Don't get angry. At least some words, right? It might have spoke. Also, the development of brain in the parietal region suggests that Australopithecus might have had some sort of a verbal communication, words to speak. Then now there is also a development of brain in now the cerebrum. Sorry, cerebellum. Cerebrum as well as cerebellum. So the development of brain in the cerebellum suggests two important things. As Australopithecus were bipedal, their hands are now free. Hands are now free. Okay. So the development of brain in the cerebellum allowed Australopithecus to do few things. They can use their hand to manipulate things. In the course of evolution, right, it is a human hand which had developed and which had given us a lot of capabilities for cultural development. Most importantly, the two bones in this region that we'll be discussing shortly, okay, which is allowing us to make this movement. Along with that, the very important thing is the opposite position of the thumb. Thumb is opposite to that of these fingers, right? Other fingers. It allows a greater grip. Now we can grip something like this. This gives an extraordinary grip. Or say how if you grip an object like this, that grip won't be so strong, right? This opposite position of the thumb, this is a very important characteristics of the primates or the animals who are close to human beings. This allowed human beings, or this allowed our Australopithecus to make fine manipulation using the hand. They can hold an object with precision and they can hit another stone to make a tool out of that stone. Now with the greater development of cerebrum, they can also, what they can do even while running, they can take one stone, they can take one object and they can throw it on others. So the greater development of brain in the cerebellum allowed Australopithecus to do this fine manipulation using hand, as well as even while locomotion, they can use the hand for multitasking. They can run at the same time they can take one twig and they can throw it on an animal. They can take a stone and they can throw it on an animal. So these were largely possible because of the development of brain in cerebellum. Okay, two important developments. Then next very important aspect of the cranium of the head of Australopithecus, that is the presence of sagittal crust. So there is one small box in your notes after the sagittal crust. There I request you to draw a diagram of a skull. I'll show you how to draw. It's very simple. So what is the sagittal crust? Sagittal crust refers to a ridge-shaped, a ridge-like bone exactly in the top of the head. I'll show you. This particular bone, you can see, right? This ridge-like bone on the top of the head. This is called as sagittal crest. This is the sagittal crest. So what purpose did this serve? So in the course of evolution, right, the sagittal crest became thinner, thinner and thinner, and it is almost completely absent. I'm not saying it's not completely. It is almost absent in human beings because among the Alaskan Eskimos, Eskimo, they live in the cold Arctic region of Alaska, where these people can eat only the hunted meat. They cannot think about cultivating any food grains here. So among the Alaskan Eskimo, this sagittal crest is still found in a small rudimentary form. If you look at the skull, right, again you can see a small bulge. Small bulge. So what is this sagittal crest and what purpose did it serve? See, some 3 million years ago, when Australopithecus were living comfortable, Australopithecus, right, they both hunted and ate meat. At the same time, they also ate hard nuts which they need to bite, break and eat. Homo habilis were the first to make fire. And it was Homo erectus who had some control over fire. That means after creating a fire, they can confine the fire within a particular region. Homo erectus. Okay. See here. But Australopithecus, they had no idea about how to make fire and how to control it. So they couldn't cook and eat the meat. Cook and eat the meat. They couldn't process the meat before eating. See, nowadays, if somebody is non-vegetarian, we may be eating this chicken. And these are, because of selective breeding, they made it in such a way that that meat is very soft, like a bread. But if you say meat is tough, meat means people need to bite, chew and eat. That is what they call it as meat. There are a few tribes in Orissa and also in coastal Andhra, near Khammam district of Andhra Pradesh. If you give this chicken to the ladies there, right, they'll throw it and say, what is this a meat? Is this a meat? Meat means we need to bite, chew and we need to eat. But hardly such a meat is available in the market now. But 3 million years ago, when Australopithecus were living, they couldn't hunt these soft animals. Most of the time, right, they'll be hunting animals and that meat will be very rough and tough and they need to bite, chew so that they can swallow it. For this extraordinary biting and chewing, they had a large and massive lower jaw. Lower jaw is a very large and massive for them. I'll show you one picture. See here how large, and it's a reconstructed one, but still see how large and massive the lower jaw is. They had a large and massive lower jaw. But the jaw alone is not sufficient. Along with this jaw, there are two muscles which helps us, excuse me, so the greater jaw alone, what is lower jaw technically called as? I told you lower jaw is technically called as mandible. Called as mandible, and the upper jaw is called as maxilla. So mandible is very important. Mandible, right? Lowermost portion, lower jaw is called as mandible. So apart from the large mandible, there are two muscles in our head region which helps us in biting and chewing. There are two muscles. These muscles are called as masseter and temporalis. So for the Australopithecus, these muscles were very large. These muscles used to be so heavy, and these muscles were further pulled here and they were attached to this sagittal crust. So sagittal crust, right, it provided some attachment area for these muscles. So I'll tell you what do you mean by an attachment area. We know muscles, right? We have our biceps muscles here. Okay, muscles everywhere, bone will be surrounded by muscles. And these muscles will not get attached in each and every point of the bone. For example, suppose if you are non-vegetarian, you might have tasted a leg piece of a chicken. If you order for a tandoori chicken, they'll give you a leg piece. This is a bone, and the meat will be they'll wrap it here and they'll give it to you so you can hold and you can eat. While eating, right, you can find one very important thing. Very easily we can eat this portion of the meat. Towards the end, there will be some meat which will be attached here in this region. We will find it very difficult to detach it, to pull it out of the bone. And suppose once the bone get dried, you can see one important thing. Here we can see some more rough patches. Here the bone will be very smooth in this area. Bone will be very smooth, but some rough patches here. These rough patches on the bone, right, these are the attachment area for the muscles. So we know how fragile these birds are, this chicken is. Even among these birds, right, even after cooking it in our pressure cooker, boiling it or roasting it in our tandoori oven, we find it difficult to detach the muscles in this region. Think for other larger animals, how tough will be the attachment areas. Okay, so our Australopithecus spent a lot of time biting and chewing. For that, right, there was a greater development of these two muscles, temporalis and masseter. Here both the muscles join here. Masseter and temporalis. Remember this masseter and temporalis. These two are the muscles which Australopithecus use, not everyone, right, we use for biting and chewing. There was a need for Australopithecus to bite and chew their food because they ate raw meat, hard nuts. So for them, there was a greater development of these muscles. This masseter used to be more massive, and the temporalis, right, they were further extended to the top of the head, and these muscles were attached to the sagittal crust. So sagittal crust provided attachment surface for these larger muscles. In the course of evolution, I told you from the time of Homo erectus. Homo erectus started keeping the meat in the fire, roasting it, processing it, and then eating. So there was a decline in this process of biting and chewing. Decline in the process of biting and chewing. So as a result, right, these muscles also become smaller and smaller. Now hardly we bite anything and eat. We just, if something, most of the food which we are eating, right, if you keep it in our mouth, it just goes inside. Can you tell me something which we need to bite and chew? Sometimes there are few roti items made out of maida. And those, right, if it becomes cold, it will be spongy, and that we need to bite, chew and eat. Apart from that, right, hardly we have any food which we bite, chew and eat now. So in the course of evolution from the time of Homo erectus, the need for a greater muscle, a greater temporalis and greater masseter declined. As a result, it became smaller, smaller and smaller, and there was no need for the sagittal crust to be there. Because these muscles, right, they are now they are not going to get extended up to this place to get attached there. So in the course of evolution, sagittal crust also became thinner, thinner, thinner and smaller, and it is almost absent among the human beings, modern human beings. Got it? Okay. So you should be comfortable with the term sagittal crust. So now I will also show you how to draw a skull. In practice, right, this will become very easy, and I will tell you, you will be in a position to draw this in a matter of 10 seconds. You start from the forehead. This is the forehead. Okay. After forehead, there will be a thick bulging bone for most of the apes. Then orbits. Some portion of nostrils. Again, one opening here. Then comes the upper jaw. And draw it like this. Then the large and massive lower jaw. And you can bring the head and you can keep it here. That's it. It's very easy, right? So I will draw it one more time. Forehead, one curve, second curve, upper jaw, lower jaw. It's very easy. Okay. We shall practice it slowly. So guys, now you should be comfortable with this very important cephalic feature of Australopithecus, that is sagittal crust. And with this, we should also be comfortable with the other anatomical terms like mandible. Mandible means lower jaw. Okay. We also discussed about two important muscles. Temporalis and the masseter. Okay, so now let us discuss the next anatomical feature. Forehead of Australopithecus. The forehead of Australopithecus, right, this is a sloping. This is one very important feature of most of the primitive apes. Forehead is the seat of intelligence. I told you there will be one ridge-like bone here in the forehead. After the here, just over the eyes. After that, the forehead used to be sloping for most of the apes. But for human beings, right, this bone will not be there, and for us, forehead will be like this. Forehead is the seat of intelligence. In the course of evolution only, right, the brain here developed, and the forehead became straight. So I'll show you one picture here. See the forehead. In fact, there is no forehead at all here. See how sloping it is. It is supposed to be, for human beings, this forehead used to be like this. And see how sloping it is. This sloping forehead is a very important characteristics of most of the primates. Okay. So now let us go to the next anatomical feature. So now I told you, right, there is one small box below the sagittal crest. In that, draw a small diagram like this. And mark this as sagittal crest. Sagittal crest. Okay. And then you can also write something. Sagittal crest is the sagittal crest refers to a ridge-shaped bone. A ridge-shaped bone in the top of the head. This provided attachment surface. This bone provided attachment surface for the muscles temporalis. Got it? You can write it in that box. So the next feature. Supraorbital ridge. So orbit, once when we die, our eyes will get decomposed very easily. And there will be one depression here in this region. That is called as an orbit. Okay, when we die. Remember, one fine day we will die. So my kind advice to you is make lot of money and spend it for your happiness. Okay, so do not make money, save. And when you think about enjoying that, right, that time, your health may not cooperate. Okay, supraorbital ridge. So supraorbital ridge, right, refers to a rod-like. It is a rod-like bone. Found over the orbits. Just over the orbits. There will be a thick bone which runs like a rod here. runs like a rod here. This is called a supraorbital ridge, and this is a very primitive feature. So in the course of evolution, the supraorbital ridge started becoming smaller, smaller, smaller and thinner, and now it is totally absent and as a small brow ridge, brow ridge, this bone is found here as a small brow ridge. But this bone, right, used to be very prominent for our apes. This is called as a supra-orbital ridge. So I will show you in this picture. Okay. This particular bone. Can you see this? This is like a rod, right? How thick this bone is. How thick this bone is. This is called as a supraorbital ridge. So what purpose did this bone serve, the supraorbital ridge serve? So when the lower jaw was largely used for mastication, that is biting and chewing, the lower jaw is large and massive. Mandible is large and massive. Using this large and massive mandible, we are biting and chewing. Biting and chewing. So when we use this bone to bite that, this pressure, right, will directly fall here in this forehead region. In this forehead region. So this supraorbital ridge, right, this developed largely as an reinforcement in this region. So what happens, suppose if there is a fort wall. Due to enemy attack, if the wall becomes weak, we'll once again build a strong wall. These are reinforcement. Reinforcement means adding some structure to make something strong. That we call as a reinforcement. So this supraorbital ridge, right, this largely developed as a reinforcement to protect the bone in this region. So that because of heavy biting and chewing, this bone should not break, right? So to give protection to the bones in this region against this excessive biting and chewing activity, supraorbital ridge developed as a reinforcement. In the course of evolution, again, when there was a decline in the biting and chewing habits, because the decline of biting and chewing activity, okay, uh, there was less pressure felt in this region and there was no need to have such a huge bone here, and this become thinner and thinner, and now it is found as a small brow ridge only. So in the course of evolution, what happened to the supraorbital ridge? Supraorbital ridge became smaller and thinner. Became smaller and thinner. I hope you are now comfortable with the term supraorbital ridge. The next very important aspect of the cephalic feature of Australopithecus. Prognathism. Gnatha refers to mouth or oral cavity. Prognathism refers to Prognathism refers to the protrusion or the projection of oral cavity forward. This is called as prognathism. Look at this Australopithecus. The head region was reconstructed. That's why the sagittal crest is not so prominent there. We can feel as if the oral cavity is being projected forward. Yes or no? We are feeling as if this region, right, is being projected forward. This is supposed to be here. So this projection or the protrusion of our lower jaw or the entire oral cavity forward is called as prognathism. And this prognathism is due to two important reasons. First one is a large and massive mandible. So in the box which I have given below that, right, you can write prognathism refers to the protrusion or the projection of the oral cavity forward. This was because this was due to two important reasons. Number one, large and massive mandible. Mandible, right? This is mandible. Mandible is a very large and massive. Along with that, even the nasal bridge, this region, right? See, this region is a bit depressed for Australopithecus. This particular portion, right, this is called as a nasal bridge. Generally, nasal bridge, right, nasal bridge means see here, in our nose, in the front portion there is a soft bone and behind that there will be one very hard bone. Very hard bone. Okay. So this one, this hard projecting bone, right, this is called as nasal bridge. For us, this nasal bridge, the surface of the face, this nasal bridge projects forward like this. The nasal bridge projects forward. So you can see in this picture. It's not so clear here. Just leave it. Okay. So because of the depressed nasal bridge, face looks more concave. Face looks more concave. Even this is responsible for giving a look as if the oral cavity is getting projected forward. Oral cavity is getting projected forward. Are you okay with this? Prognathism refers to the protrusion of lower jaw or the projection of the oral cavity forward. This was largely due to two important reasons. The lower jaw mandible, right? Mandible is large and massive, and the face is concave. The face is concave largely because of the depressed nasal bridge. Depressed nasal bridge. Okay. Hope you are comfortable with this particular term. That is prognathism. So there are a few other important anatomical features left in the cephalic region itself. That is the position of foramen magnum, then the presence of mastoid process and the occipital condyles, and also how the zygomatic arch look like. So let us continue our discussion tomorrow, and I hope you are comfortable with what we have discussed here. So in a separate column of white paper, try to note down what are all the anatomical features which we have discussed today. First and foremost thing, I told you what do you mean by cranium. Okay, what do you mean by cranium? So cranium refers to a collection of bone which covers and protects our brain. I told you a few very important regions of the cranium. Frontal region in the front, parietal in the top, occipital and temporalis in the side. Okay, cranium and its important region. Then now we discussed about sagittal crust, and two important muscles. Temporalis on the masseter. Temporalis and masseter. I also told you lower jaw is technically called as mandible and the upper jaw is called as maxilla. Upper jaw is maxilla, mandible, maxilla. We also discussed about prognathism. Hope what these things are a bit interesting. Correct? I also told you what do you mean by an attachment area or attachment surface in a bone. Okay. Hope I think all those right who missed to study biology or those who aspire to become a doctor and who couldn't be right, I hope you all will be happy reading all these things. This is a reading about our own anatomy, right? So this will create lot of interest and the enthusiasm, and let us continue our. So I'm going very slow. So initially, right, as I am introducing you to all of the anatomical terms, it will take some time. So it will take 2 or 2.5 lectures for me to finish this Australopithecus. But once when this is done right, in a single lecture I can finish Homo erectus. Thus in one more lecture, right, I can finish Neanderthals. So only the beginning, only the starting will be slightly difficult, and I want you to understand these anatomical terms. If you have any doubt in that, please, I will repeat it n number of times, because this is one area which is really tough in anthropology. Okay, and this is one very good scoring area. If there is a question from, there will be some question from this area and you are supposed to answer, your examiner will look into that whether you have answered this or not. And you are not supposed to leave this in choice. This is one very important technique in scoring very high marks. There will be questions from this A part as well as the culture theory part, and you need to be thorough in this. You should answer this irrespective of anything. That will only fetch you a very good mark in anthropology. Okay, so let us continue our discussion tomorrow. Until then, bye bye. Have a great day. Thank you.